You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. More space missions you should know. A few months ago, my episode on Space Missions You Should Know generated a huge amount of positive feedback, as well as a flood of suggestions for spacecraft that I didn't talk about. Who doesn't love spacecraft? We live vicariously as astronauts through them. They are our eyes and radio ears into deep space, going where we can't go, flying through the rings of Saturn, exploring asteroid worlds straight out of science fiction, and literally peering straight into the beginning of time. Today, we're going to look in detail at some of the most amazing and inspiring space missions from the past, present, and future. As we did before, let's begin with some missions from yesteryear that you may have forgotten about, starting with Stardust. In 1999, this NASA probe launched with the goal of flying through the tail of comet Wild 2 and returning a sample of its dust to Earth. On its way, it practiced by making a pass of asteroid 5535 Anne Frank. After 5 years of space travel, Stardust positioned itself in front of Wild 2 and allowed itself to be overtaken by the faster-moving object. Once inside the tail, Stardust opened a hatch and extended an arm with a collector coated in aerogel. Approximately 1 million particles penetrated the aerogel. 2 years later, Stardust passed the Earth and ejected the sample return capsule. It entered the Earth's atmosphere at Mach 36, faster than any other man-made object before or since, and decelerated at up to 34 G. It parachuted safely and landed exactly on target. Ever since, the dust has been examined by citizen scientists using the distributed computing project Stardust at Home. Results so far have been amazing and have included liquid water, interstellar dust particles, lots of organic compounds, hydrocarbons, and other fun stuff to excite the enthusiasm of astrobiologists, most significantly, the amino acid glycine, one of the building blocks of life. The first time we've found it in a comet. Chandrayaan-1. Launched in 2008 by the Indian Space Research Organization, this lunar probe orbited the Moon and died in 2009. Although its mission was shorter than planned, it still did almost everything that was hoped for. Its greatest accomplishment was the discovery of far more water on the Moon than anyone had expected. In the old days, we thought the Moon was dry. Then, analysis of moon rocks showed a tiny amount of moisture locked away. A series of lunar missions into the early 2000s found signs of small amounts of ice at the poles. But Chandrayaan-1 rewrote the book and found huge amounts of water throughout the lunar regolith, plenty right at the surface near the poles, and potentially including great frozen aquifers in the form of underground sheets of ice. Thanks to Chandrayaan-1 and its impactor that searched for water all the way down, we now have much better confidence in our ability to build a self-sufficient, permanent moon base. Now, let's move into the present and look at some of the missions being developed today for launch tomorrow. Psyche. With a planned launch date of 2023, a spacecraft is currently being developed to visit the strangest object in our solar system, and they're both named Psyche. The object lives in the asteroid belt, and it is a 200-kilometer diameter solid ball of iron-nickel metal, the only one like it known. There are a number of ways it could have come to be, but the leading theory is that it's the metallic core of a planet about the size of Mars that was destroyed and stripped of its rocky crust and mantle in violent collisions with other bodies. It's 4 million cubic kilometers of solid metal, enough to build tens of thousands of Death Stars. Probably. Psyche, the spacecraft, will spend 5 years traveling to Psyche, the mysterious metallic object, using its ion thruster powered by solar panels. Once arrived, it will enter orbit and spend 2 years mapping and characterizing the object. There being no other known objects like Psyche, It's probably the only time anyone will ever get such a good look at such a thing. Studying exoplanets. The starscape of space missions has been transformed with the discovery of so many exoplanets, a breakthrough greatly accelerated by the Kepler mission, launched in 2009, and now in the 8th year of its planned 3.5-year lifespan. Nobody expected Kepler, with its dedicated photometer pointed at a single patch of the Milky Way, to find so many exoplanets. We're surrounded by thousands of other worlds, but there's a limit to what we can know about them. This target-rich environment has triggered a reshuffling of priorities at NASA, and studying the exoplanets we've located has risen high on everyone's priority list. The main goal is to obtain spectroscopic signatures from them, something we can't yet do with today's telescopes, but which tomorrow's telescopes are being designed around. This gets into hardcore organic chemistry, but when we study Earth's spectrum today, as viewed from space, and when we work out what it would have looked like in its early days when the predominant life forms were simple purple bacteria, we find there are certain telltale signals that would be visible to the right equipment even at exoplanet distances. Astrobiologists have worked out every imaginable scenario for the chemistry of life, and we know to look for a signature called the infrared edge to find the simplest life, and most significantly, the red edge to find more advanced life. And even if alien life is based on one of the other possibilities, though carbon is still by far the most likely, those compounds have other signatures that we also know to look for. I suggest reading articles about the red edge to learn more about this. Next, we'll take a look at two of the proposed next generation space telescopes. While the James Webb Space Telescope is taking over where Hubble left off, we need something in the works to take over from the Webb. 2 of the 4 proposals are LUVOIR and HABEX. LUVOIR. The Large Ultraviolet Optical and Infrared Surveyor would be the most insane telescope ever. While the James Webb Space Telescope has a mirror 6.5 meters across and sees mostly in the infrared, LUVOIR's mirror would be almost twice that size at 10 to 12 meters and will see in UV, visible, and infrared bands. Among its nearly unlimited abilities would be the capacity to characterize exoplanet spectra. Like the James Webb, LUVOIR would live at the Earth's L2 Lagrange point, a gravitationally stable spot 1.5 million kilometers from Earth, from where the Earth blocks most of the blinding light from the Sun. Even though that's too far away for manned missions to service, like we did with Hubble, LUVOIR is designed to be serviceable by robotic vehicles. HABEX. Another of the 4 telescope proposals is the Habitable Exoplanet Imaging Mission, or HABEX. It's got nowhere near the comprehensive abilities of LUVOIR, and its mirror would be only a fraction the size, but what it has is the most specialized and hyper-capable exoplanet characterization engine ever conceived. It's built around a dedicated coronagraph, a telescope that completely blocks out the sun or star at the center of the view. Blocking it suddenly makes everything else in that distant star system visible, including planets and gas clouds, things that are impossible to see with a regular telescope because of the star's glare. HABEX's killer feature, though, is its star shade. When you want to really block out the light from a star, you want to physically put something in the way. HABEX will incorporate a second vehicle, a round star shade the size of a baseball diamond, which would fly independently with its own propulsion system, some 50,000 kilometers away. Its edge is lined with shapes like flower petals that will reduce a complicated problem with gravitational lensing. Europa Clipper and Europa Lander. From far in the future and far away in the cosmos, we come back to our home system, to 2 missions that will investigate one of our own worlds where we have high hopes of finding life. If Jupiter's ice moon Europa has hydrothermal vents at the bottom of its vast oceans, we expect to find life almost to a certainty, just as we've found it around Earth's own deep-sea vents. But those hydrothermal vents are not a given. Jupiter's gravity constantly kneads the little world with powerful tidal forces. Its thick ice crust may absorb all those tidal forces, leaving a cold, rocky core. But if it doesn't, if the core itself stretches every 3.5 days as it completes each tidally locked elliptical orbit of its massive neighbor, then that core may be hot. The ocean may be liquid, and there may be massive hydrothermal interaction between the two. Europa Clipper hopes to answer much of this question with its ice-penetrating radar and other instruments by making 45 ultra-low-level flybys of the moon, dipping as low as 25 kilometers, so low that if Europa had Mars's Olympus Mons, the spacecraft would crash into it. Its ultra-high-res maps should find a great landing site for its sister mission, the Europa Lander. Europa Lander is planned to touch down via the same sort of sky crane that brought the Curiosity rover to Mars. Europa Lander will operate for just 21 days until its batteries run out, digging in the ice and directly testing it for signs of life. Currently, the Europa Clipper is funded and hoped to launch in the late 2020s. The Europa Lander is not yet funded. Who doesn't hope it will be? We love to anthropomorphize our little robotic friends in space. As this episode is being produced, Cassini is in the middle of its grand finale, its final dives through the rings of Saturn. As it makes each dive, it turns to point its dish antenna forward as a shield. After each dive, it swings it back toward Earth to transmit its images. But when it makes its first and only descent into the atmosphere of Saturn itself, tearing in like a meteor, it will have no such protection. Cassini will keep its antenna trained directly on the Earth, as its cameras and sensors collect every bit of data they can, even as its surfaces scorch, its spars break away, its circuits go dark. Finally, the hypermach blast furnace and aerodynamic forces will tear it apart, and as its bits streak and crumble through that largest sky ever witnessed, all that will remain will be a digital image of that magnificent view shimmering toward Earth as a radio signal. Yes, we love our courageous little spacecraft. Long may they live. A quick shout-out to the countries with a higher percentage of listeners than my own United States. Number 1, Australia. How you going? Number 2, New Zealand. Kia ora. Number 3, Iceland. Kvasearu. Sorry, I tried. Number 4, Canada. Hey, Hoosers. And number 5, Norway. Hi. Don't forget, have plane ticket, will travel. Drop me an email at brian@skeptoid.com. I'll come give a screening of the new movie to your Skeptics in the Pub group. You're listening to Skeptoid, a listener-supported program. I'm Brian Dunning from Skeptoid.com.